Hello friends and welcome to my channel. So today we are going to start with these general steps in a finite element analysis. So we will see one by one what are the steps in a finite element analysis. So basically there are 8 steps in this finite element analysis. So we will start with the step 1. Step 1 is a discretization. In this discretization we will get some problem. So any problem which is structural maybe or another into a finite element model. So finite element model means it's a combination of these nodes and the elements. So these nodes and elements formation is called as meshing in finite element analysis. So we can convert according to the problem. If it is a 1D problem, we can convert it into a link element. We can use a triangular or quadrilateral if the problem is 2D. If it is a 3D or solid, we will use tetrahedron and hexahedron. So we have to assign this is total nodes and the elements in the system. For example, here we have defined this structure into finite element model. So we can assign the number from here 1, 2, 3, 4. Likewise, we will give the element numbers. According to that, we will give node numbers. So these are the node numbers, and then next step is to define the boundary condition. Here we have some fixed supports and roller supports. So accordingly, for particular nodes we are going to give the supports as this is displacement is 0, this displacement is a 0, and force is applied on these nodes. So we will convert the structural problem or any other problem into a finite element model. So this is the discretization is the first step. Second step is identifying the primary unknowns. So what is mean by primary unknowns? So we will get first unknown, that is displacement in the structural analysis. Means if we do the structural analysis for stress, we have to find out the displacement first. Then we will see heat conduction analysis. In this analysis we need to find out the element temperature. So this is the basic unknowns, so which are called as a primary unknowns. In CFD analysis we have to know about element velocities. Then we can find out different unknowns which is required in this analysis. For example, here it is a displacement. So primary unknown is a displacement. So secondary unknown becomes a stress and the strain. So stress and strain can be found out using this stress strain relationship or stress displacement relationships. So these relationships are coming from the theory of the elasticity. If we know the primary unknown temperature, then we can find out the heat flux and the heat flow by using some relations. So those are called as a secondary unknowns, and these are called as a primary unknowns. So identify which is the primary unknown in your problem and then start. So next step is our third step, selection of a proper interpolation function. Interpolation function are also called as a shape functions. So in this problem, if we define this problem with the help of these elements, so we need to define a proper shape function for these elements. Suppose the elements are simplex element, we will use simple linear polynomials or interpolation functions. If it is complex, then we will use quadratic shape functions. If it is multiplex elements, we will use cubic shape functions. So explanation about simplex, complex and multiplex elements you can find out here by clicking the eye icon here. Okay, so interpolation function defines the shape functions because we will getting the values at the nodes. So intermediate values in between the elements we will get using these shape functions. So that's why shape functions are more important to get the accurate results, because nodal values are may not be accurate as per as if we solve the linear ways. So we need more complex and multiplex elements and quadratic and cubic shape functions. Next step is a derivation of a element equation. Means we have to define each element with its equation. Means how many elements are there, that much equations are to be formed. These are the equation. Force vector is equal to stiffness of the element and multiplied by displacement vector. So there are two methods mostly used, Rayleigh-Ritz method and Galerkin method. So these method used some where stress analysis is required. So we use minimum potential energy approach in Rayleigh-Ritz method, and suppose for problems we use a Galerkin method. So for each element we will get this force is equal to stiffness into displacement, and then next step is step 5, derive overall stiffness equation. Means if there is a n number of elements, we will get n number of equations for each element, and this n number of equations we need to add together to get a global stiffness of that system, and force are added accordingly, we will get the force vector. Displacement are added accordingly, we will get displacement vector. To form this global stiffness matrix, each element is connected to the next element with some nodes. According to that, we will connect these all elements together to form this global stiffness matrix. So this stiffness matrix gives you the whole stiffness of this your problem. Now once we get whole system equation, that is force is equal to stiffness into displacement, so we have to solve these system equation to get the primary unknowns from this overall stiffness. So there are many methods we can solve this to find out this Q value. Q is a primary unknown. So we can simply take this stiffness matrix to other side, make a K inverse and multiply by its force vector. So we will get directly the displacements, or we can use Gauss elimination method. What happens in Gauss elimination method? We have to convert this stiffness matrix into upper triangular matrix, and one by one we can, if we multiply last value of this displacement, we will get the exact value for this last displacement. So likewise we can solve this equation simultaneously. We will get all these primary unknowns, and we can use again relations to get the secondary unknown. This is the step number 6. Step number 7, that is to get the secondary unknowns. Once we got all displacement here, we have displacement vector. So if we want to find out the strain, that is epsilon, we will use strain displacement relationship. So strain displacement relationship comes from the theory of elasticity. We can derive these relations, and if we put the value of displacement in that equation, we will easily get the strain in each element. So if we want to find out the stress in the element, there is a relation, stress strain relationship. So stress strain relation derived from this Hooke's law. It is applicable for 1D, 2D and 3D. So if we know the strain, we can find out the stresses in the each element. Now if we find out the at the middle of these elements or somewhere inside the element, so we can use the interpolation function, that is shape function, to find out the stress inside the element. Okay, and the last step is step number 8, display and the interpretation of the results. So once we done with the finding out the primary unknowns and the secondary unknowns, we have to collect the data, result data. There is two methods, that is a tabular data method. Second one is a graphical display method. So in tabular data, what happens, we can prepare a table accordingly. So in that there will be stress, there will be element or strain or any positions, their stresses, strains. So we can give the tabular data. By using this tabular data, we can prepare a graph on x-axis and y-axis or any other method we can use for graphical representation. So it comes in the tabular data. And the next is visual display. Visual display means we use the graphics like suppose this is a plate which is stressed, so we will get maximum displacement here, minimum displacement on this side. So we will get the static with the contours, and we can play the animations. Animations means how minimum to the maximum value is to be changing from minimum to maximum or maximum to minimum. We will get the animation. We can save that in the form of video and we can show in the presentation. In that we can explain about how the load is going to vary, how the von Mises stresses are going to vary. Then we will get to the conclusion about the finite element analysis or finite element method of this total problem. So basically it has 8 steps and it is explained here. So thank you so much guys. Please subscribe for more videos. Thank you.